Meet Jim. Jim works for a large original equipment manufacturer. Jim has a big job. He's responsible for his company's supply chain. In the old days, when his company made everything under one roof, things were pretty straightforward. Jim bought lots of raw material, negotiated a fair price, made parts, and shipped products. Today, instead of making everything in-house, Jim buys parts from all over the world. Most of Jim's part suppliers buy the same raw materials, but buy them from different distributors and mills and pay different prices. What was once an easy sourcing process has now become very complex. Sure, it would make sense for everyone to collaborate on the purchasing of common raw materials. After all, 30 to 60% of Jim's part costs is directly related to the raw materials that go into them. But he knows that getting part suppliers, distributors, and mills to work together is a lot like herding cats. And when Jim needs a part, information about the raw material that goes into that part flows slowly and incompletely through the supply chain, like a game of telephone. Near the bottom of the supply chain, Jill, who's a distributor of raw materials, has to guess what Jim and his part suppliers will purchase. It's a daunting task, since she only has a vague notion of which part suppliers will buy raw material from her, when they will buy, and in what volumes, sizes, and specifications. And this often leads to long lead times, speculative inventory, and late parts that cost more than they should. Fortunately, Jim discovered a way to help Jill and everyone else in the supply chain. It's called material demand aggregation, a process invented by Supply Dynamics. Here's how it works. First, Jim hired the smart folks at Supply Dynamics to help him figure out what raw materials go into his parts. This step is called part attribute characterization. It's a software and engineering-driven process that takes a blueprint and documents all of its raw material attributes, things like form, alloy, grade, specification, and size, all the information that a mill or distributor needs in order to take care of their customers. Then, Jim was able to combine this information with his finished part production schedules to create a detailed raw material forecast for each of his manufacturing sites and part suppliers. He also shared this forecast with Jill, the distributor, and with the mills. And by using a web-based raw material forecasting and fulfillment solution, Jim was able to automate everything and share updates with his entire supply chain in real time. This solution didn't replace or change any of Jim's existing IT or engineering systems, it complemented them. It also ensured that part suppliers that committed to purchasing raw material through Jill actually did so, and that Jill wouldn't be left holding the bag. This not only made Jim and Jill happy, but it delighted Jim's part suppliers and the mills, because everyone finally knew what materials were needed, when, and in what volumes and sizes, and to what specifications. And that helped everyone obtain a more competitive price and better serve their customers.